In this lesson, we'll talk about parent functions and translations. Um, so with this question, we're going to just look at these parent functions and also review some of the ways of describing functions that we've done so far. So y equals 5 is a horizontal line. Y equals x, it's a line like that. Absolute value x is like that, but it goes up on the other side. And we know what the parabola looks like. Alright, so why don't we do domain of all of these. The domain is all the x values that have a point on the graph. So we can go all the way to the left, and that line will go all the way to the left. It'll go all the way to the right. So the domain is all real numbers. This goes all the way to the left, all the way to the right. Same thing. We can go all the right, left, all real numbers. And the same for that one. The range is all the y values on the graph. Well, here there's only one y value, and that's 5. So we would write it like that. Here the y values go down to negative infinity, up to positive infinity. So the range is all real numbers. Here we don't have negative y values. We have a 0 and then positive. So it starts at 0, goes to infinity, and we are starting at 0 and including it, so we have a bracket there. And that'll be the same for the parabola, starting at 0 and going to infinity for the range. The x-intercept, where does the graph touch the x-axis? There's no x-intercept. Here it's 0, 0. The point 0, 0, and this can be confusing too. We have interval and ordered pair, so we have to know the difference between them. Again, 0, 0 for the x-intercept and 0, 0 for the x-intercept. The y-intercept is 5, 0, 5. And then y-intercept will be the same as the x-intercept for these. Symmetry. Can we change y values? Positive 5, negative 5. No, that's not on the same graph. But we can change x values. Negative 1, positive 1. They're both on the graph. If you change the x value, then it has y-axis symmetry. Over here, if we change the x value, we have a positive 1, negative 1. Well, we don't have the same y value, but we do change both of them. Positive 1, positive 1, negative 1, negative 1. So that'll be symmetry to the origin. Here we can change the x, so that's symmetry to the y-axis, and y-axis symmetry here. Also, when we have symmetry to the y-axis, it's called an even function, if it is a function. Continuity, these graphs have no missing points. The domain is all real numbers. I guess that doesn't mean it has to be continuous, but these are all continuous. So we'll say, where are the functions continuous? They're continuous on all real numbers. So these are x intervals where the functions are continuous. And behavior. So that's the limit as x goes to infinity is 5. The limit as x goes to negative infinity is also 5. That's the end behavior. The limit as x goes to infinity is 5. This is I'll just put a y there. The limit of y as x goes to negative infinity is also 5. Here, as you go to the right, y goes to infinity. As you go to the left, y goes to negative infinity. So we have the limit as x goes to infinity is positive infinity. The limit as x goes to negative infinity is negative infinity. And that's end behavior. So on the next one, going to the right, positive infinity, going to the left, positive infinity. So the limit as x goes to infinity is positive infinity, and the limit as x goes to negative infinity is positive infinity. And that'll be the same for the parabola. All right, and then decreasing. Let's look up here. This is never decreasing. This is never decreasing. This is decreasing from negative infinity to 0. So decreasing from negative infinity to 0. And that'll be the same on the parabola. It's decreasing from negative infinity to 0. And where are they? Increasing. Where are the graphs increasing? The constant is never increasing. The line y equals x is always increasing. And we look up here, the line is always increasing. The values are always increasing. So for all real numbers, the graph is increasing. And the other two are just increasing from 0 to infinity. Okay, so there are a couple questions that say describe functions in all of these ways, so that's a review of how we describe them. Okay, a few more parent functions. And we're going to go over 1 up 1, over 4 up 2, because we're doing the square root. So there's that parent function. Make sure we know these points. So it's 0, 0, 0 cubed is 0, 1 cubed is 1, negative 1 cubed is negative 1, and then we go up to 8, and over 2. 2 down 8, 2 up 8, and we have that parent function. And if we just memorize these 2 points and know that there are asymptotes, that can help us graph that. So we have a 1, 1, negative 1, negative 1. All right, and that's called the greatest integer function. And here's the pattern we need to remember. Closed circle, open circle, closed circle, open circle, closed circle, open circle. Okay, so those are some parent functions we're going to transform. Okay, so we're just doing translations today, and one way to identify the type of transformation is whether the 3 is inside with the x or outside. So when it is outside, it's not changing the x, and that means it'll be a vertical change. When it's inside in parentheses with the x, that'll be a horizontal change. We could just make a table, XY table, and do all the computation, but here is another way to do it. If we have x squared, and then we either create these with a table or just memorize them. These are the points of x squared. And then we do what would happen if we have a vertical change. Are we going to be changing the x or changing the y? Well, this is outside of the x. It's a vertical change, so we're going to add that to all the y values. And we didn't change the x values. Then it's nice to know where the parent function was or is. We can put a dotted line through there. Then we'll just plot these points. -2, 7, -1, 4, 0, 3, 1, 4, and we can see the translation up. Okay, pause the video and try this one. So we just see that the 1 is not inside parentheses with the x, so that's a vertical change. We're going to subtract from the y values. So we go -2, 3, -1, 0, 0, -1. I plotted all of those points. We can also plot the parent function. All right, so now we see changes inside parentheses with the x, so that means it's going to be a horizontal change. Every time we have a horizontal change, we're going to do the inverse of whatever operation is being done to the x. So here we're going to subtract 3 from all the x values, and we're dealing with the parent function, y equals x squared, and let's just use the same points. And then we're going to do x plus 3 squared is going to be subtracting 3 from all the y values, all the x values. Minus 3 from that, minus 3 from that. So we subtracted from the x values, and we don't change the y value. One, two, three, four, parent function. And now we just plot these points, and that will be a horizontal translation. So we go 1, 2, 3, 4, 5, up 4, negative 4, up 1, negative 3, up 0, and translated to the left. Pause the video and try the next one. And remember that we have to do the inverse. When it's a horizontal change, we're going to add 1 to all of the x values. Don't change the y values. So we have parent function, and we go negative 1, 4, 0, 1. We get those points, and it translated 1 to the right. So now we're going to graph the greatest integer function, a transformation of the greatest integer function, and let's also do a radical. So, this plus 2 and this minus 2, we already know what to do with that. We've seen that with the parabola. All we have to do is get the parent function points. So if we look back, when I gave you those points for the greatest integer function, why don't we just use the closed circles? And those were, if we just look at this, we have negative 1, negative 1, 0, 0, 1, 1. And those were right here. I'm just using these points. Negative 1, negative 1, 0, 0, 1, 1. Using these. And then we know that where the open circles are going to go. And we see 2 is outside. It's not inside with the x. That must be a y value change, a vertical change. So we're going to just add 2 to all the y values. And those are the new points in the transformation. And if we plot the parent function, it'll help us see how it changes. I should have a dotted line there, but I didn't do it. Make it dotted. Now we plot these points. Negative 1, 1, 0, 2, 1, 3. And then we know it goes like that, and we can continue. Open circle, closed circle, open circle, closed circle. So we see this graph move up. Okay, pause the video and try that one. So we know radical x has these points. And then we see 2 is inside with the x. That's a horizontal change. But we have to remember that when you subtract, when it says subtraction, we're going to add to the x values. parent function, and then we're going to go 2, 0, 3, 1, 1, 2, 3, and go out there. So we have a horizontal translation. All right, we have two transformations, and try that one. If you need a hint, remember that we used these 2 points, and then we just know that the graph goes through curved like that. So there's the parent function. So let's focus on these 2 points and see where they get moved, and then we can sketch the graph. Pause the video and try that. So here's the parent function. And we're just going to take the -1, -1, and the 1, 1. We have a 1 with the x, so that's going to be a horizontal change. We'll do the inverse of addition to the x values. Let's subtract 1. Subtract 1. And we have a +2 that's outside. That's a vertical change. We're going to add 2 to the y values. So those are the new points. -2, 1, 0, 3. It will also help to move the asymptotes. This has a horizontal asymptote and a vertical asymptote. We had a translation to the left, so let's put that right there. And a translation up. And we can see the transformed graph. All right. We have these points, and then we have the V. So if you use those points to make a table, and then you can transform them with the x and the y. So pause the video and try that one. So we have an inside change. That means we're going to subtract 1 from all the x values. We have an outside change. That's a vertical change. Subtract 2 from the y values. So -2, -1, -2, -1, -1, -2, and 0, -1. Alright, so we see that the parent function used to be there, or the parent function is there, and the transformation moved left 1, down 2. Alright, and we'll stop there.